Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 1 and 2 class. Today we're going to be wrapping chapter 8 up. Sorry about that. And we're going to talk about variation. I know I titled this direct variation and inverse variation. Your book has it titled as just simply variation because in essence there's really four. There's direct variation, inverse variation, joint variation, and combined variation. But joint and combined variation use direct and inverse properties, so that's why I'm teaching it under the guise of direct and inverse variation. Let's just think about a really common example, guys. A lot of you have done this before in your life. The time it takes to hear thunder, okay, varies directly with the distance from lightning. It's modeled by this equation right here. Y equals 1/5 x, okay? Where y is the distance in miles and x is the time it takes to hear the thunder. Haven't you guys ever been with someone? Usually it's, I think it was my dad that taught me. I think it was my dad and we heard thunder. And as a little kid you get scared, right? Didn't they tell you, okay, count? Right? Well, what do you think they were counting? Because every 5 seconds, according to this model, every 5 seconds that you count, that represents 1 mile away that the lightning is. So if it takes you 20 seconds to count, it's 4 miles away. Okay? This is what's called a direct variation. Okay? The distance in miles from where the thunder comes varies by this constant. It's 1/5. So whatever the distance is, or whatever the time it took for you to count, okay, how long it took to hear the thunder, it's 1/5 of the distance. So if x took 5 seconds, then that means it's 1 mile away. If it took 25 seconds, then that means it's 5 miles away. And this can go on forever. This 1/5 though never changes because that is how it varies with the independent variable x here. That is what direct variation is. A direct variation is a relationship that can be represented by the function in the form of y equals kx, where k cannot equal 0 because, of course, if k equals 0, you just have y equals 0 in that case. There is no function. The constant of variation, this k, okay, there's a constant of variation for direct variations k, is the coefficient of x. It is being multiplied to x in direct variation. And if you solve for k by dividing x to both sides, you will see that k equals y divided by x. Now, it's very important for you to understand that the goal of direct variation, my friends, or inverse variation, or any variation, is to find the k. That's what we're finding. Once you find the k, you can plug it in to any equation because the equations are really, really simple. Okay? You with me so far? Okay. You can determine whether an equation represents a direct variation by solving for y. If you can write an equation in the form of y equals kx, it is a direct variation. This is very important. Again, it's a direct variation because this k is affecting this x directly. So whatever's happening to this x something's going to be happening to this y based on the k. The x is independent, the y is dependent. The k is what you're solving for. And when you rewrite the equation, k is going to be constant, not the y or the x. Yes, sir? Oh, you are so awesome. I'm so proud of you. My boy just asked, what's the difference between this and slope-intercept form. Slope-intercept form, my brother, has a quote-unquote K, but it's called M. A slope-intercept form has a B, my man. If you add anything, you're changing how it directly varies. It doesn't directly vary anymore. Because again, we go back to our first example. When x is 5 seconds, we know that whatever the time is, the distance is 1/5 of the time, correct? It's not 1/5 of the time plus 2, or plus 1, or minus 7, because that changes everything up. In order for you to have a direct variation, it's got to be y equals kx. So, what is the difference? The difference is this b right there. If your y-intercept is 0, though, guess what? That linear equation is a direct variation, because m would be your k in that case. It's a good question. Thank you. Does that make sense? Okay. Now, how does this work, Moral? Before we get into how it works, let me just give you a little concept summary. Direct variation concept summary. Y varies directly with x. 1. When the function is in the form of y equals kx. Nothing being added to it, nothing being subtracted to it. When x increases, y increases by the same factor. Even though the distance for the lightning example, the distance was 1/5 of the time. As time increased, didn't distance increase as well? It just increased by 1/5 of a factor. But it did increase as x increased. Does that make sense, guys? Okay. When x decreases, y decreases by the same factor. And when the k is constant, and you notice direct variation, when the k is constant, so it remains the same for every point x and y. So part 1, determining whether or not you have a direct variation. All you got to do is solve for y. And when you solve for y, you get the form of y equals kx. It's a direct variation. And then you're going to know what your k is, because k is being multiplied to x. So here, divide by 7. Y equals 2/7 x. So that's a big fat yes. What's my k? 2/7. Y equals kx. It's in the correct form. And you know your k, your constant is 2/7. B. I'm going to subtract 4x to both sides. I got 3y equals negative 4x plus 8. Divide by 3. No. This is y equals negative 4/3 x plus 8/3. This is a big fat no. Why? Because of that plus 8/3. Is this a linear function? Yes, it is linear. Is it a direct variation? No. Why? Because I added something to the x. Yes, sir, you have your question.
Basically, if there's any where it says 0 on the next side, right?
That's exactly right. That's why I said it's got to solve to be y equals kx. Anything added to it or subtracted to it will not make it a direct variation. Thank you, my brother, for your honesty, sir. C. Subtract 4x to both sides. 5y equals negative 4x divided by 5. Y equals negative 4/5 x. That is a big fat yes. What's my k here in this case? Negative 4/5. Very good. Very good. And D. I divide by negative 3 to both sides. This is a linear equation. Yes, it is. It is a linear function. Yes, it is. Is it a direct variation? No, because of that. So if I give you any function and I say to you, determine if this is a direct variation, solve for y. If you get y equals a k times x, you have a direct variation. If not, you're out of luck. Does that make sense? Now, let's show you how to work this with word problems, because this is the big part of this. You will see this on the SAT, and you're going to destroy it while everyone else is going, what is going on here? What's going on here? Suppose y varies directly with x. They're always going to tell you if it varies directly, if it varies inversely, if it varies jointly. They're always going to tell you. So y varies directly with x. Right off the bat, you know that you're talking about a y equals kx. Okay? Because it says directly. And y equals 35 when x equals 5. What direct variation equation relates the x and the y? What is the value of y when x equals 9? Guys, all you got to do is solve for k. Two ways to do that. You could remember right off the bat that k equals y divided by x. In that case, k equals 35 divided by 5, which is 7. So my formula now is y equals 7x. Y equals k, which was 7x. Once you have that, what is the value of y when x is 9? Thank you. When x is 9, 7 times 9, y would equal 63. Now, Mr. Morrow, I'll be honest with you. This is easy. I like it. But I don't know if I'm going to remember that k formula, Mr. Morrow. There's a lot of equations, Mr. Morrow. Please. You're right, brothers. So, worst case scenario, plug and chug, man. Plug and chug. Y is 35, right? I don't know what k is. That's what I'm looking for. X is 5, right? Solve for k, my brothers. K still is going to equal 7. Y still equals kx. Y still will equal 63 when x is 9. But if you don't want to learn two formulas, that's fine. Another thing just to think of, if you know that y equals kx, don't you just divide by x to find k? So I'm not really making you memorize a new formula. I don't want you to see it that way. I want you to memorize one formula and then be able to manipulate it. Does that make sense, my brothers? Thank you. Suppose y varies directly with x, okay? That's a direct variation. Y equals kx. And y is 10 when x is negative 2. What direct variation equation relates x and y? What is the value of y when x is negative 15? Well, k equals, well, I'll do it this way. Well, no, let's do it the right way. K equals y over x. So thank you. Someone had said it. Very good. That's negative 5. So my equation, y equals negative 5x. What is the value of y when x is negative 15? Negative 15 times negative 5 is 75. Excellent. Ding dong, the witch is gone. Not too bad, right? You with me, my brother? You guys with me? Yes, sir. Why? Where? How do I get negative 5x? Okay, thank you, son. Y equals kx, right, my brother? K equals y divided by x, correct? Didn't they give you a y and didn't they give you an x? So k is negative 5. My direct variation is y equals kx. What was my k for this example? Negative 5. And then I just plug in the value of x to my direct variation equation. You feel me? Thank you, sir. May I continue? Great honesty. Thank you. May I continue? Okay. Now, Sometimes they're going to give you a table, okay? So I want you to remember this. Remember that if the constant of variation is the same for each pair of data, then the relation is a direct variation. If they give you a table and say, determine if this is a direct variation or an inverse variation, you're going to have to test the k's. In order for this to be a direct variation, k, which is y over x, must be constant. That means it's got to be the same for every single y over x. Feel me? So 6 divided by 4, that's 3 halves. 12 divided by 8, that's 3 halves. 15 divided by 10, that's 3 halves. Are the k's all equal? So this is a yes. What would the equation be? Y equals k, which is 3 halves, x. Excellent. Was 3.2 divided by negative 2? Negative 1.6. Great. What's 2.4 divided by 1? 2.4. Are those k's the same? You can stop right now. Not direct variation. Not. .25 divided by negative 3, believe it or not, is negative 0.75. Negative 7.5 divided by 1, remember, because k is y over x. This is also going to be negative 0.75. Negative 3 divided by 4 is also negative 0.75. So this is a big fat yes, it is direct. And what would my function be? Y equals negative 7.5x. Very good, boys. Does that make sense, guys? Not 0.75, not 7.5, 0.75. Thank you, sir. Thank you. Make sense, guys? All right, now, inverse variation. Okay, don't stress, please, please. I know you're looking at this, you're going, oh my God, what is this man doing to us? I promise you, it's not that hard. The same concepts apply to the inverse of variation, except that the x varies now inversely. The k is still going to be in the numerator. The k is still going to be constant. But this time with an inverse, you're dividing the x to the k, not multiplying. In inverse, you have y equals k over x. If you solve for k, k equals y times x. K is still the constant of variation. K still cannot equal 0. Okay? Same exact concepts, but when it's inverse, you're dividing x to k. When it's direct, you're multiplying to k. When it's inverse, you're dividing x from k. Now, getting the direct and the inverse can lead us into joint and combined. Joint variation occurs when several factors are being multiplied to the k. Notice what always remains the same. K. K is in the numerator, and when I have a joint variation, you're going to have 2, 3, 4, 5 different things that multiply together, that multiply to that k. That's called a joint variation. And I promise you we're going to have examples now. Combined variation occurs when k is being both multiplied and divided by different factors. Combined, think about it. It's a combination of direct and inverse. The direct combination is up here because they're multiplying. The inverse combination gets affected down here because it's a division. Does that make sense? So joint, you're multiplying everything to the k. Combined, multiplication and division. Direct variation, multiply. Inverse variation, divide. Before you stress out, let me show you how easy this is with examples. The weight W that can be safely supported by a 2-inch piece of lumber varies inversely with its length. So the first thing you are to do always is first set up the equation with no numbers, just variables. And what did they just tell you? W varies, so you know there's a K, inversely with length. So am I going to multiply? Or thank you. Guess what? That's half the problem. That's half the problem right there. Now it says, experiments indicate the maximum weight a 12-foot pine 2x4 can support is 400 pounds. Find a function that relates the maximum weight to the length L for any 2x4 pine. Guys, plug in what they gave you. Didn't they give you the weight of 400? Didn't they give you the length of 12 feet? So that's my K. So what is K in this case? Well, I multiply by 12. 4,800. So what is my function? W equals 4,800 divided by L. Now for part B, determine the maximum weight a 15-foot 2x4 pine can sustain. Well, my weight, it's 4,800 divided by 15. W is going to equal, what is that, 360? 320, thank you. 320 pounds. And that's how you work this. Now be honest, this wasn't that hard, was it? Yes, sir. Okay, let's see. For part A, find a function. Yeah, so this would have been the answer for A. And then this would have been the answer for B. Does that make sense, my brother? Okay. It's all in the reading, my friends. Determine if this is, whether this gives you a direct variation or inverse variation or neither. Well, all right, boys. So, in this case, a lot of people can get confused. But remember, you either have direct variation, which is y equals kx, where k, bless you, is y divided by x, or it's going to be inverse, which is y equals k over x, where k equals xy. Okay? So whichever one of these is constant all the way through, that's going to be your indicator that that's the type of variation it is. So let's first try y over x. Let's try direct. 15 over 2 is 7.5. 7.5 over 4 is not 7.5. So I can stop right there. No, it's not direct. Now, don't just say, oh, it's inverse, Morrow. No, because it could be neither. Let's see if it is inverse, though. In this case, we're trying to look for k, which is x times y. We want that constant for everything. 2 times 15 is 30. 7.5 times 4 is 30. 3 times 10 is 30. 2 times 15 is 30. So yes, It is an inverse. What is my formula? Y equals K over X. Does that make sense, my friends? Okay. Now, the fun part. Suppose that X varies inversely. Immediately, right off the bat, write it down. Okay, it's an inverse. That's how I save myself, always here. It's not because I'm so smart or so intelligent. I just read. I like to make my life easy, brothers. Suppose that X and Y vary inversely. Done. It's inverse. I write it immediately. Now I plug in. And X equals 4 when Y is 12. Well, heck, they just gave me this. Solve for K. K equals 48. So my equation is Y equals K, which is 48, over X. Now, they can give me any value of X I want, and I can solve using my inverse variation. Yes, sir? You cannot write the function as K equals. No. Because the function, remember, always has to do with a dependent, independent, and that's my K. So no, it can never be K equals as the function. K equals Y times X in this case to find the K. But that's not the equation. Does that make sense? Now, they love to make these word problems very verbose. Don't be scared of that. Verbose just means very wordy. The force F of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly. Tang, 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 tang. That should be an indicator. Okay, we're talking about jointly. So the force F varies jointly with the area A of the surface and the square of the speed V. Do you see what I just did? Of the wind. All I did was write down what I read. Now, a wind of 30, plug in, miles per hour, blowing on a window measuring 4 by 4, measuring 4 feet by 4 feet, has a force of 150 pounds. What is the force on the window measuring a 2 foot by 6 foot caused by a hurricane force wind of 100 miles per hour? What's the only thing I'm missing? My area. But what's area? No, it's not 12. It's 4 by 5. So that'd be 20. So literally, my friends, let's solve for K. Yes, sir? I did square it right here. That's why 30 is being squared. Okay? So I have 150 equals 900 times 20. What's that? 18,000, right? So K times 18,000 divided by 18,000. Do not simplify this. Do not turn into a decimal. Divide that by 3. By 3, so we've got 5 600ths. But no, I can do more than that. I could have divided it by, yeah. So what's this going to be now? 1 over 120. Okay, that's my K. So my formula now is my force equals 1/120th times the area times the velocity squared. That's my formula. Now, what is the force on a window measuring 2 feet by 6 feet caused by a hurricane force wind of 100 miles per hour? Well, in this case, they're looking for the force. And that equals 1 over 120 times my area, which in this case is 12, times my speed, which is 100 squared. So that'd be 1, 2, 3, 4 zeros. And literally, force in this case would equal, get rid of this, get rid of that, get rid of that, 1,000. 1,000 would be the force. Talk to me. I will not solve this next one. Let me just set this one up for you, okay? Please. The electrical resistance of a wire R varies directly with the length of the wire L, so directly, and inversely with the square of the diameter of the wire D. So inversely, we got to put it down there to divide. You feel me?
Juan Carlos Cardoso reports immediately to the attendance office. Juan Carlos Cardoso.
Okay, so real quick, if the wire was 432 feet long, that's your L, and had 4 millimeter diameter, that's my D, and has a resistance of 1.24 ohms, that's my R. Plug all of those in, find K. Rewrite it with your K, and then plug in the new information, and you'll have your answer. Does that make sense, my brothers? God bless you. Have a great day. Hope you learn a lot. Thank you.